Okay, so at the moment we are looking at exponents. We are going to be looking at the distributive law tonight. So yep, and our upcoming courses, we've got patterns, functions, and then algebraic expressions. Okay, just a quick shout out to those of you who have just joined. I'm Teacher Jen. I'm just here with you tonight. Teacher Sam is not here this evening, and she will be back with you on Wednesday. Don't worry, you are in the correct class. You are where you need to be. Okay, so before we jump into our new rule, we've already done a couple of rules. I had a look through Teacher Sam's lessons, and you've done where you've got multiplication with bases and you've done division. So if someone can sort of help me out, I'm going to put a question up, just something nice and easy over here. If I had x to the power of 4 times x to the power of 2, can someone tell me what I would get in that situation? What would that equal? And how would I know what to do?
Don't be shy, my people. I know y'all are active. You can raise your hand. The way that
yes, excellent. Thanks. Nice job, guys. Beautiful. Okay, so when our bases are the same, and we're multiplying, so we're multiplying over there, then we add our exponents. So that was the first rule that you guys learned together. Let me do this all in blue so that we being consistent a little bit. Okay, then the next rule you guys learned was if you had division. So if I had x to the power of 5 over x to the power of 2, what's that going to be now? Let's see what you remember. So this would have been from your last lesson. Careful, careful. So that would have been a perfect answer if they were being multiplied together. Yes, x to the power of 3. Beautiful.
Well done.
Okay, so when we have, and they have the same base like that, and we are subtracting, we're going to take that power and we are going to subtract it. We're going to say 5 minus 2. Remember, if you're ever feeling stressed, you can always write it out the long way. You've got 5 x's at the top and 2 x's at the bottom, and you can just cancel, and you will see that you have got 3 x's left at the top. Okay. All right. One last question with this, and then we'll jump back into number 1. What if this was the other way around? What if I had x squared at the top and I had x to the power of 5 at the bottom? What would my answer be then? Be very careful. And remember, if you are like in doubt, you can always write it out the long way. You'll be able to see where your x's are left. X to the 3 is definitely going to be involved.
Let's go, guys.
Oh, okay. X to the minus 3. I don't hate it.
We need to remember. Hey, my people, y'all need to remember.
Let's see. Let's try and draw it out. So let's do it the long way. If we had 2 x's at the top and we have 5 x's at the bottom, okay, and this x cancels with that x, and that x cancels with that x. I agree with you guys that we have these 3 x's over here, but are they at the top or are they at the bottom? Those 3 x's. Are they at the top or at the bottom? Where are those x's? The numerator or denominator, top or bottom? Have a look at it carefully. So exactly. So it's going to be to the -3, and it's because they're at the bottom. But we don't like writing with negative exponents. We like writing with positive exponents. So we would write this as 1 over x to the power of 3. So when we're doing division like this, if the exponent is bigger at the bottom than it is at the top, then the answer is going to be at the bottom. So if we have a look at this example over here, we've got x to the 2 at the top there and x to the 3 at the bottom over there. So just be very careful with how we would cancel those out. Okay. The other important thing to keep in mind with this question is remember to deal with signs, numbers, and then variables. So you're first wanting to look at what is my final answer going to be if I have a negative and a positive. Then you're going to look at your numbers. So how can you simplify 3 over 6? And then you're going to look at each of your variables. Okay, so give this question a go. See if you can solve it. And then we'll do it together on the board. But if someone is feeling brave and wants to answer for the class, then please feel free to pop your hand up and we will go through together. So we've got signs that we're going to deal with, and then we're going to deal with numbers, and then we're going to deal with variables. And for variables, we're going to do each variable separately. So we're going to do our x's, and then we're going to do our y's.
Let's go, my people. Chanchela D, Chanchela Dario. I hope I'm pronouncing it nicely. It's already their hand are up. They are ready. Let's do this, guys. Yeah.
I'm going to give everyone 1 more minute to give it a go by themselves, and then I'm coming for that hand.
Let's go, Linati. Kelebogile. I see you guys. Let's do this. Sisi Gazu, are you doing it? You must write it down on a piece of paper so that you can correct your work. There we go.
Okay, let's see. What does my volunteer have to say?
Okay, ma'am. So like I got 3x to the power 3xy, and that's like x and y is like to the power of 1. So
okay, there's some things that are good in there, and then there's some things that we're going to work through a little bit. So, but let's just let's talk through it together because you've got some good things happening. So first of all, when we look at our signs, is my answer going to be positive or is my answer going to be negative?
positive because there's like 2 numbers.
But there's one negative and one positive.
Oh, negative plus.
Do you remember? Yeah.
Yes,
Okay.
yes,
No, these are good. These are good mistakes. Mistakes in maths are my favorite thing. You are doing all the right things. Making mistakes in maths is how you learn and how you get better. So you take those mistakes proudly. Okay. So definitely. So signs, we've got one negative and we've got a positive, which means our final answer is going to be a negative because we've got one of each. Okay. Now, I want you to think about it like this. For your numbers, you've just got this 3 over the 6 like this. If I asked you to simplify that as a fraction, how would you simplify that fraction?
Oh, simplify it. So I take the x to the power of 3.
Oh, don't look at anything else at the moment. Just look at this dude over here. How can I just simplify 3 over 6?
I divide it by 2, which makes it 3.
No, don't panic. So if we're looking at a fraction like this, we're trying to think what number can go into both of them, right? So we'd say, well, 3 can go in 3.
3 can go to 3. Oh,
exactly.
It's a half.
There you go. You got it.
Well done, Sensei. Well done.
Perfect. Okay, so my signs was a negative, then my numbers are becoming a half. Then we're going to start looking at our variables. So our first thing that we're going to look at is we've got this x to the 2 at the top and x to the 3 at the bottom. So if I had to write that out the long way, I would have 2 x's at the top and I would have 3 x's at the bottom. So when you told me your answer was x to the power of 1, I liked it, but where does it belong? Does it belong at the top or does it belong at the bottom?
At the bottom.
Yeah, so we're going to put that x to the power
Sensei.
1 down there. And then the last thing we have to deal with is our y's. So where are our y's going to go?
Also at the bottom.
Also at the bottom, exactly.
Well
and so then
done.
that's going to be our final answer.
Yes, ma'am. Thank you, ma'am.
Nice. Good
Well
work.
done. Nice one, Sensei.
So guys, the whole thing with these questions is, I know that you probably hear it all the time from Teacher Sam, is the SNV all over the screen. I can't tell you how much it helps though, if you take a question like this and you break it up into small little steps and you just do one thing at a time. So you first just look at your signs, then you just look at your numbers, then you just look at your variables. So like one thing at a time. Okay, Taniko, do you have a question or was this to answer?
Oh, no, ma'am. I just wanted to answer.
Okay, well, I will look for that hand in the next one. Nice job, guys. Okay, if you want to take a screenshot of this question, please feel free. And I'm going to scroll down a little bit so that you guys can see the next one so long. So try and think about everything we spoke about in question 1 and try and apply it into question 2. There's some things that make question 2 a little easier. So hopefully you will enjoy it.
Yeah, network is just a problem. I'm not sure if it's me only, but Teacher Jan is cutting a little bit now and
Oh no,
then.
am I cutting, guys? Can the rest of you hear me?
Maybe
Maybe-
it's my network.
Yeah, let me know if you guys are having difficulties hearing me talk.
So far, it looks good. They're
Okay.
definitely my network. Yeah.
Okay. Okay, good. And as soon as we have a brave soul who is ready, pop that hand up and see if you can talk me through question 2. I'm very excited. Bali, I love the capital letters. Very enthusiastic.
Bali's emphasizing you. Ma'am,
Yeah.
Yolanda is your network.
Yeah, I don't know. Okay, we have got our first volunteer. Exciting. Hello, my love.
Hi, ma'am. Can you hear
Okay,
me?
I can hear you beautifully.
So I got 1/2.
Okay,
X.
let's work through it for me. So just so that we can help everyone else on the call. So when we look at our signs, what would it be? Positive or negative?
It would be positive
Can you tell me why?
because positive divided by a positive is positive.
Beautiful. Mwah.
Go.
Okay, excellent. Love it. Okay, we've done some.
Then
Let's look at our numbers. 2/4. What's that going to become?
it's gonna be 1/2.
Beautiful. Numbers. Done. Okay,
Ah.
variables.
X and y to the power of 2.
Okay, let's look at our x's. If we have one x at the top and we have one x at the bottom, they're going to land up canceling each other out. So they're going to go away completely.
Oh,
And then for my y's, if I have 2 y's at the top and I have 1 y at the bottom, what am I going to be left with?
1
Good, 1 y. And where is it going to be? At the top or is it going to be at the bottom?
at the bottom.
Oh, have a look. Have a look here.
Oh, at the top. Sorry.
Yeah. Okay, so wherever the
Dale.
exponent is bigger, that's where it's going to land up.
Yeah.
Okay, nice job. Awesome. Good work. Guys, if anyone has any question about these first 2, please feel free to ask. Like, don't feel stressed and think that you can't ask. You're welcome to put it in the chat or put your hand up if there's anything that's happening that's confusing you. But so far, you are doing great. You're doing very, very good. Yes, hello.
I live to.
I'm trying. Oh, there we go. Hello.
Hello,
Hi.
Hi.
how are you?
How can I help?
I don't understand anything because I just joined.
Okay, what are you feeling? Which sort of parts are you feeling the most confused by?
When you're working it out.
From the beginning?
Yes, ma'am.
Okay, so I think, were you here for the lessons with Teacher Sam last week?
No, this is my first lesson actually.
Okay, so that makes sense. So don't panic if you're feeling a little bit lost. All of the lessons are online, so you can watch them all through the Watobe website. You can watch all the lessons that they started with this exponent section. So I think it's probably just because you're 2 lessons behind, so it's feeling a little bit stressful. But just keep going with the lesson as we go, and then when you get a chance, watch the lessons that you missed last week, and you should be good to go. Okay.
Thank you.
Okay.
And we're doing many examples, guys. For everyone who's confused, you're allowed to ask which parts don't you understand. So
Yeah,
we go
there you
step by step, and you'll definitely catch the rhythm. You'll see.
Yeah. 100%. So all of you, this is your first lesson. Don't panic. The others have been doing exponents for a week. So just try and follow as much as you can. All right. Guys, this one's nice and easy. We don't have any signs to deal with. We don't have any numbers to deal with. For those of you who have not seen this, let me write it out for you here. So the S stands for signs. So if we have got a positive and a negative, then it's going to be negative. And if we have 2 of the same, it's going to be a positive. So that's dealing with signs. Numbers is just your actual numbers. And then V stands for variables. So we're looking at our letters. Okay, so in this one over here, we're dealing with 2 positives. So we don't need to stress about our S. We don't have any numbers, so we don't have to deal with our N. So all we have to focus on are our variables. So we only need to look at those 2 over there, and we need to look at those 2 over there. And we're going to try and figure out what our answer is going to be. If you can do this one, you will have mastered the idea of when the denominator is bigger and when the numerator is bigger. So just give it your best go. I'm just going to write something here on the side, just as like a little helping hand. Taniko, I see your hand, and I'm going to be coming for you just now. So I'm going to write x squared of x to the 5. That's going to be equal to 1 over x3. That should help. So Nelson, I'm liking those numbers. I just want you to be careful about where it's going to be. So is it going to be in a numerator, or is it going to be a denominator? Are they going to be in the same place? I'm going to give you guys 1 more minute, and then Taniko is going to talk this one through for us. Okay, let's deal with this step by step. Taniko, can you start by talking us through the X's?
Ma'am, I actually had a question.
Excellent.
I just wanted to ask, if the numerator is bigger than the denominator, can you still minus it? Like, can you minus it bottom to top?
Yes. So like if we look at our X situation over here, this number is bigger than this number. So we would say 19 minus 15, but we always are going to put the answer where it was bigger. So because the 19 was bigger, it's going to be at the bottom.
Oh, okay. Thank you, ma'am.
No problem. Guys, I think that would have helped with a few of you with how to work this out. So just remember that when we're dividing like that, you just need to be careful about where it's bigger. So here, 19 is bigger than 15. So we still see 19 minus 15, but wherever it's bigger is where it has to stay. So if we have a look at our y's, okay, our y's over here, we've got 22 and then we've got 17. So 22 minus 17 is going to give us 5. Now we have to look at where our y's were bigger. Our y's were bigger at the top. So it needs to stay at the top. So wherever it's bigger is where it's going to stay. So for the direct message that just came in, when we're doing division with exponents, then we subtract. When we do multiplication, then we add. Okay, the hands that are up, if they are to answer this question, do you mind popping them down for me? But if they are up to ask another question, then keep them up and I'll try and work my way through them. Okay, I'm just going to go from the top and work my way down. Hello.
Hello, ma'am.
How can I help? How can I help?
Ma'am, with the x2 over x5 is equals to 1 over x3. And on top of that, ma'am, you said x5 over x2 plus actually minus x5 is equals to x3, ma'am. Is it minus, ma'am?
Yes, so
But-
here, you are minusing, and here you are also minusing. But
Okay,
here the x's are bigger at the bottom, and here the x's are bigger at the top.
So, ma'am, so that's the only thing, ma'am. So what if, can I say, is it possible, because here on my notebook, ma'am, it says I can say 5 over x over 5, ma'am, and y2, ma'am. It says I can do the same thing, ma'am. Is it possible, ma'am?
Can you explain what you're meaning? X over 5?
X over 5, ma'am. No, sorry, ma'am, my mistake. X5 over y2, ma'am.
Like that.
Is it possible, ma'am, that I can also do the same thing as you did here, ma'am, like on the other one?
There's nothing further you could do there, because they don't have the same base. This has got an x and this has got a y. But
Okay,
if they
ma'am.
were both
Thank you, ma'am.
x's or if they were both y's, then you could. If that helps. Okay. Yeah, no, I know, Blaise. I think it was because of the connection on the other side.
Oh,
Hi, sweetheart, how can I help?
oh, ma'am. What about the one in front of the x and the y?
The one, oh, yeah, you can definitely write the one if you want to. If you want to have a one there, 100% you can put the one there.
I thought
It's
you were
just the
supposed
same
to
as like,
no, like, cause like I thought you were supposed to add them. So
oh, okay. So when we're doing our division like this, we're subtracting. The one that's there is just because we'd basically be saying 1 divided by 1 is 1. So that's where the 1 is coming from. But
okay.
so you can have it, but it's the same way as how you don't need to have that 1 in front of the x. It's the same as just saying x.
Okay, thank you, ma'am.
No problem. Okay, guys, I do see I've still got a couple of hands up. I just need to pop on to our next little part of the lesson. If you don't mind, if you can pop those questions in the chat for me, that would be great. And I promise I'll try and deal with them there. Okay. For those of you who are feeling a little bit confused about the situation where we have numbers that are bigger at the bottom versus bigger at the top, the easiest way to explain it is honestly just to write it out sort of the longer way. So I'm just going to move this for now. Okay. If we are talking about numbers, let's just use the example of x squared over x cubed. Okay. If I'm working out that example, if I had to write that out the long way, it's the same as me having 2 x's at the top and 3 x's at the bottom. Okay. These x's would cancel with those ones, and anything divided by itself is left with 1. And so my final answer would be 1 over x. So if you think about it, it's the same as saying the 3 minus the 2, and then wherever the x's were bigger, that's where it's going to stay. So because x to the power 3 is bigger, they're going to stay at the bottom. If we had the exact same question, but we flipped it around, so if we had x to the 3 at the top and then x squared at the bottom, and I wrote it out, I would have 3 x's at the top and 2 x's at the bottom. And so those two would cancel with those two, and I would be left with just x. And you can write x over 1, but that's the same as saying like 5 over 1 or 6 over 1. Anything divided by 1 is itself. So it would just be an x. And so there again, what you're doing is you're taking this 3 and you're minusing the 2. The 1 is just because of the numbers. So it's just saying that 1 divided by 1 is 1. You don't need to have that 1 there. It's not a necessary one. You can have it if you want. It's the same as if you have 1x, it's exactly the same as x. So it's not necessary, but you can have it. So those of you who are getting confused about when we're subtracting, technically we are doing the same thing. It's just that we're looking for where the number is bigger. If we say 15 minus 19, we're going to get a negative number. So if we had done that, we would get x to the negative 4, y to the power of 5. And we're not allowed to give answers that have a negative exponent. And so then that would need to move down. So when exponents move down, they become positive. But that's a concept we'll talk about a little bit later in high school. So I don't want you to panic about it too much for the moment. For now, I only really want you to focus on ever the exponent is bigger, I want you to take the bigger number minus the smaller number and put the answer where it was originally bigger. There is a brain break today, don't you panic. We're going to quickly go over our rule for what we're going to be focusing on after brain break, and then we'll jump into the brain break, okay? So you have done 2 so far. You've done 2 laws. You've done your multiplication law, and then you've done your division law, what those 2 just covered up now. Now we're going to be doing the distributive law. So that, well, let's call, yeah. Okay. So the way that this law works is if we have something, so like let's have an x and we have to the power of 2, and that's to the power of 3. If we have something where we have a power to another power or an exponent to another exponent, we multiply those 2 together. Because what this would actually mean, if we wrote this out the long way, is we've got x squared times x squared times x squared. And remember, when we're multiplying and they have the same base, you're adding all of those. So it would be 2 plus 2 plus 2, which would give us 6. Right? And the easiest way to get there, and so that we don't have to write out this long way, is we can just multiply it like that. So the rule here is when you have an exponent that is, I'm trying to think of a better way to write it. Ooh, goodness. Dropped a whole little box situation. She's actually going to kill me if she gets here.
So
She's boxes of God. She'd be like, no, where's my box? An exponent that is to the power of another number. Then you multiply the exponents. Okay. So what we're doing here is we're saying that 2 times 3. So as another example, if I had y to the power of 4 to the power of 3, what would that equal? If I had y to the power of 4, that was to the power of 3, what would that answer be? Think about what we've just said now. What we do to those 2 exponents.
yes. Well
Good.
done, Alicia.
Perfect. Y to the power of 12. Exactly. Okay. Let me see if I can try to trick you. If I have 2 to the power of 3 to the power of 3, what's that going to be? I'm trying to trick you. Don't fall for my trap, guys.
Lite, do you want to give it a try? I see Lite's hand is up.
Oh, Lite, hello.
Yes, ma'am.
Have you got an answer for me?
Yes, ma'am.
What did you get, Lindsay?
2
Yeah.
2 cubed times 2 cubed times 2 cubed. No, ma'am.
Oh no, I think the connection cut out there. I'm seeing some great answers happening in the chat over here though. It definitely is going to be 2 to the power of 9. So as soon as there's a number, we start panicking. We think we're going to have to do something to that number. We're going to be like, oh no, it's going to be an 8, and then I'm going to do all kinds of things. We don't worry about it. We do the exact same thing. We have a power, we multiply it by that power, and we get our next answer. So 2 to the power of 9. Don't overthink it. Okay. I saw a few people have like 6s popping up and 8s. It's very normal reaction. It's just, we're just not going to do that. Nice job, guys. Awesome. I think let's quickly jump into our brain break, and then we will try and do a couple of questions using this new law. Zoom down
Time
quickly.
to stretch. Please stretch, my people. Y'all deserve a break. You've learned a
Yes.
lot today.
Stretch it out, guys. Take a break, take a lap around your room, and once you have lapped around wherever you're working, tell me if you can figure out this glorious little question mark here. And then we've got our joke from Teacher Sam, if we can get the answer to this brain break.
You know, I love Teacher Sam's joke, guys. You better get it right. Let's do this the correct way so we can see the joke, okay? See some good things going on.
Yeah, I like that. 4 plus 4 plus 4. It's a good start. So we know that our sunflowers are 4. Good. So think about what that means for our second line. Second 8, good, okay. So that means that sunflower is 8 and that sunflower is 8. I like it. So if I have 11 times 8, that's going to give me 88, but I have to also add this 8 here. So that's going to be a problem. There we go. 10. Nice. Okay, because then we're going to have 10 times 8 is going to give us 80, and the 80 plus the 8 is going to give us the 88. So now just be careful about what that means for this one over here. So yes, yay, I see some of the correct answers coming through, which is great. So those are going to be 5 over there, which means that this is going to have to be 7, because 7 times 5 is 35, and 35 plus 5 is 40. Then we've got 14 over there, and 5 over there, which gives us the beautiful answer of 74. And I saw a couple of you who got that, which is great. Nice work, guys. Woohoo!
Nice job. We've earned to see the joke, guys.
Okay, I haven't seen the joke
Correct.
yet either. So we get to all look at the joke together for the first time. Let's have a look and see what Teacher Sam gifted us with today. What subject is algebra? Oh,
She loves this judge.
teachers have jokes are
love
so
them.
lame. I love them so much.
Also.
Ugh.
Yeah.
Okay. I hope your brains feel braked. We're gonna jump back and see if we can do a couple. Hey, don't wow me. These are teachers' Sam's jokes.
Sorry, I needed to unmute myself to laugh at that. So, wow,
I feel like I'm like getting heat from this.
but Lara,
Okay.
that's what makes it funny. That's why
Yeah.
I'm laughing. That's the whole point.
Okay, let's give some of these a go and see how we can get through these next few questions. So this one is very, very similar to the one that I just given you, where I was trying to trick you using numbers. You all should feel quite confident in this question. We've got 2 to the power of 3 to the power of 2. So what am I going to do to those exponents? And then what is my final answer going to be? I'm just going to write a little example over here. If I have 2 squared to the power of 4, that would be x to the power of 8. Yes, guys, look at those beautiful answers coming in. We are going to multiply them together. We're going to say 2 to the power of 3 times 2, which gives us 2 to the power of 6. You don't need to show the step. I'm just writing it in there so you can see what we've done. Awesome job, guys. Yes. Let's try another one. So now this one, I want you to be very careful. Do you see how this -3 is not part of my brackets? Okay, it's outside of my brackets. So we're not going to worry about it for the most part. We're just going to look at this over here. So just be very careful with this question. Don't try and fall for the trap. That -3 is not inside the brackets. See if you can give me an answer to this question here. Yes. Do we have an answer?
So, ma'am, I think maybe it's like -3 brackets x to the power 6.
I love that. I love that so much. That's beautiful. Do I need to have those brackets there? Because those brackets mean
No,
times. So what could my final answer be?
-3 and x to the power 6.
Yes. Beautiful. Nice. 100%.
Salir.
Okay. Smashing this, guys. Awesome work. Okay, so now we're happy with A, we're happy with B. Let's try to take it up a notch. Let's try have a look at C. Remember, guys, if you're having questions sort of while this is going on, just pop them in the chat for us so that we can try and answer as we go. Okay. This one I want you to be careful with. There's a whole bunch of stuff happening in C that we need to be careful about. I'm just gonna, as a little reminder, when in doubt, write it out. Okay, obviously can't do that if the power is like to 112, but when the power is something small like this, then we can. So if we wrote this out the long way, we would have -2x to the power of 4 times -2x to the power of 4. That might make it easier for you to see what to do. We'll see. I'm happy with 2 different answers for this question. So I'm seeing some good things popping in. I'm really liking the x to the power of 8 that's coming in the answers. I'm really liking that. But I want you to be careful with yours. if I had to look at this question this way, so if I looked at it the long way, where I've written it out the long way like this. If you were given this question in algebra and you were asked to simplify, and you followed your ideas of sign, numbers, and variables, right? We've got a negative times a negative. What do two negatives make when we have a negative times a negative? So think about our signs, numbers, variables. If we have two negatives, what does that make? A positive, exactly. Okay, so our answer is definitely going to be positive because there are two negatives being involved over here. Then if we had a look at our numbers, okay, we've got 2 times 2. What is 2 times 2? What does that give me? Four. Okay, so if you wrote it as 4 or if you wrote it as 2 squared, I would be happy. Okay, and then like all of you had there, you had your answers for your x's beautiful, x to the power of 8. That was 100% right. 100% right. So you could write this two ways. You could write it as 4x to the power of 8, or you could have written it as 2 to the power of 2, x to the power of 8, and I would have also given that mark. But the thing is with these ones, when we have negative signs involved, they're trying to trick you. They're trying to make sure that you give the wrong answer because they know you're going to give it as a negative answer. And that's why writing it out the long way can sometimes be very helpful. Because if we can see the two negatives, so we're good. No, I did. I saw your answer, Lethe, and it was great. I just didn't want to ruin it for everyone else.
Take screenshots.
You guys are doing amazingly. Exponents is like one of the toughest sections and stays with us forever. So understanding these like base rules is really important. Okay. Renee?
We are winning, guys.
Winning. Okay. My first question to you with this question before you jump in, because now we have to combine the ideas that we learned in B and C. Okay. Is that -4? Is that -4 in the brackets? Or is it not in the brackets? That's my first question to you. So be careful because we have to take the logic we used from question B for that. And then for D, this part over here, that's we're going to use our logic from B, and this we're going to use our logic from C. So if I had to write this in a different way, I would have -4 times -b cubed, -b cubed. That would be another way of writing this. Just putting that there to help you. We'll see. Maybe it helps, maybe it doesn't. We'll see. I'm seeing some good answers popping in. Oh, the feeling it's going to be a negative answer. Okay, okay.
I got a
See.
feeling. It's a good feeling. Ay, amorela.
Okay, I'm liking that. Yes, we're getting there. We're getting there. Good, guys. Yes. Smashing this. Okay, so if we have a look at this part over here, if we have a look at the part in the brackets, okay, this is the logic we used in our last question. This -4, nothing's happening to it, right? And we're timesing it, so I'm just going to put it in a bracket. The negative and the negative, so they're going to make a positive, and then we're going to have b to the power of 6. So that 3 times 2, that gives us 6, or in this case, we would have said 3 plus 3. We'll get to the same place. But in here, we don't need that bracket because that just means 4 times b to the power of 6. We're going to have negative 4b to the power of 6. And that's going to be our final answer. Nice work. Yes, it's going to be 6, not 9, because we're not saying 3 squared. We're saying 3 times 2. You did say so again. Okay. Let's try another one like this. This one's super easy. You guys should be able to do this one in your sleep now. What is E? What is the answer for E? You probably don't even need to look at it. Oh, good. I'm glad you're enjoying the lesson. Yes, exactly. X to the power of 35. All we have to do is we've got to multiply those two together. Nice and easy. Glorious. I think we have time to do a couple more questions. So if you would like, please take a screenshot of this. And then we're just going to scroll down over our little brain break and we're going to do a couple more questions. Cool. Let's scroll.
We have the poll today.
Yeah. Don't worry. I will make sure that we stop in time.
Okay.
If you're still feeling a little bit confused and a little panicky, don't stress. Specifically, if this is like your first lesson, it's okay. It's normal to feel stressed. The best advice is to watch the lessons the teacher taught last week, because that will be sort of the introduction to exponents, and then maybe give this lesson a rewatch and you'll be like, oh, it all fits together now. I don't want you to stress too much. Yeah, I know school is very tiring. I understand that. No, Lise, we are definitely seeing your right answers. I promise, 100% I'm seeing your right answers. I've congratulated you every question.
Yeah, I think it's more of giving other people a chance so that they don't copy your answer, because we will mention and say you have a correct answer and everyone will copy your answer. Then we won't know if they got it correct by themselves or not. But well done. Well done.
I'm going to write something here that might help you guys out a little bit. So I'm going to put in brackets x squared y to the power of 4 all to the power of 3. That's going to equal x to the power of 6 y to the power of 12. So that concept should help you. And remember, if there isn't a number, there would be a 1. Oh, I'm seeing some good answers.
Of course she is. She's really good, Botlale.
Remember that 2 would also have a power of 1. So if there is no power, then we have to give it a power of 1 so that we know that there would be a 1 there. So we're just going to use the same logic that we've used over here. We're going to distribute that 2. So we're going to say 1 times 2, 2 times 2, 1 times 2. So 1 times 2 is going to give us 2. So 2 to the power of 2. 2 times 2 is going to give us 4. And 1 times 2 is going to give us 2. So you can either leave your answer in that form, or you could leave your answer as 4x to the 4 y squared. And on that glorious note, I actually think we're going to have to call it a night because you've got your poll evening tonight.
Yep, that's true. Woo, why do I have to create a poll?
Oh no.
Open on my side.
Is the poll not an option?
Can you click it on your side? I don't
I
know.
don't
On
have a
my
poll
side,
on my side either. I've got no poll. It says no polls or quizzes.
guys, I'll be on a panic mode over here because it's okay, my people. Well, I know how many were here.
Yeah, I think that's fine. You
Then
know what, guys? And that's cool. I think like because of that, we can squeeze in a quick answer.
can
Like
squeeze
we can
one.
squeeze in one more question. We can
Yeah,
squeeze in another question. So for those of you who are feeling a little bit lost about this one, remember you can always write it out the long way as well because it's being squared. So it's writing those brackets out twice. And it's sometimes easier to see what to do because then you can see, okay, 2 times 2 is 4. Your x squared and x squared would be x to the 4, and then y times y would be y squared. So some people just find that much easier, and it's totally okay to write it like that. The place where most people make a mistake in this question is they leave the 2 as a 2 and they don't make it 2 squared. Again, you can use that same concept here. You can write this bracket out twice. Sorry. So you can write this as negative x squared y to the 3, negative x squared y to the 3. And that should help you. So just remember your signs, numbers, variables. So in this case, what does a negative and a negative create? If we have 2 negatives that we're multiplying together, it's going to be good. It's going to be a positive answer. Then look at your x's and then look at your y's. Yeah, but lucky because you're doing so well. No, why are you feeling not and dumb? Don't know. You're like getting all the answers right. So we're gonna have x to the power of 4, y to the power of 6. Some people might find it easier to think of that as a -1. And so you're saying -1 squared, which is +1. But I don't know. I don't want to confuse you with like a situation. Oh my goodness, no, that's not true at all. I promise there's lots of people who are probably panicking. You're definitely not alone in this. Exponents are like a scary section. They feel very overwhelming. It's like numbers and letters all over the page. It's totally normal to feel a little bit stressed in this section. And the best thing to do is just practice. Practice, practice, practice. And I promise exponents is easier.